So we've got this weird hanging box. I don't know why anyone would ever hang a box like this, but
people do weird things.
Yeah.
I have to accept it.
So we've got a rope, a rope, a rope, and a box. So it's tempting to do a free body diagram of the box because that's what we're used to doing. And so the free body diagram of the box would be pretty boring though. It would just be gravity's pulling down, tension's pulling up. It doesn't really help us out too much. So the more interesting and useful place to do a free body diagram is of this point right here, because it's at the center of everything. So that's going to give us the most information about what's going on. So if we go ahead and draw that dot down here to get ready for a free body diagram, we know that it's got a tension force pulling it directly to the right from this rope. We know it's got a tension force pulling it up and to the left from this rope. And we know that it's got the box pulling on it via tension straight down, like that. So two of these vectors that we've just drawn look pretty nice because they're perpendicular to each other. So this is in the x-axis, this is in the y-axis. Don't need to worry about splitting it. This one, on the other hand, definitely does not lie on an axis. So we'd want to draw in its components. And so since we know nothing is moving in this picture, we know that there can't be a net force. So net force needs to equal 0. That means all of our y-axis needs to cancel out and all of our x-axis stuff needs to cancel out. So the only two things that we have going on the y-axis is this and this, so they must be equal and opposite. The only two things that we have going on the x-axis is this and this. So those two things must be equal and opposite. So what's the question asking for?
Oh yeah, the angle of theta.
Okay. So we know that that angle, so the angle of theta there is going to be the same as this angle here. Do you see that, where that would be the case? Okay. So does it give us any values? Does it tell us the mass of the box or anything?
It says that the wire fastened to the wall is horizontal and has a tension of 38. And then the one to the ceiling has a tension of 59.
And doesn't tell us anything about the box.
Mm-hmm.
So we know this tension is going to be equal to the mass of the box times gravity, but we're not even going to end up needing it. So what we want to do here is, since we know this vector and the x component of this vector need to be the same number, yep, 38 newtons. So how would we express this vector symbolically using this theta and this hypotenuse magnitude? So how would we, if all we knew was theta and 59 newtons for the hypotenuse?
Cosine?
Good, we'd use cosine because it's the adjacent side to this theta angle. So we could say cosine of theta is equal to adjacent, so that'd be like the x component, over hypotenuse, which is 59. So we could rearrange that and we could say 59 times cosine theta equals x. And since we know the x component needs to be the same as this 38 newtons, instead of writing equals x, we can just say equals 38. Now we've got an equation with only one unknown, so we can solve for the theta.
What'd you do? Inverse cosine?
Mm-hmm. Yeah, so let's go through the algebra. So we would divide the 59 over, so then we'd be left with cosine theta equals 38 over 59. Then to get the theta by itself, we'd say theta equals inverse cosine of that fraction. So I got 50, 49.9.
I feel like I was gonna try to make it a lot more difficult than that was.
That wasn't too bad.
Yeah, once you
I just
draw the
didn't
free
know
body
that you
diagram.
had to do like the rectangle part of it.
Right.
Like drawing the rest of the components in.
Yeah, physics, right triangles are like your best friend. And sometimes you gotta be careful because
When I
sometimes,
don't do a right
yeah,
triangle, it's wrong. When I do a right triangle, it's wrong.
exactly. Sometimes you can make wrong right triangles. And so you gotta be careful of that. But yeah, whenever you've got slanted vectors, you always wanna make it into a right triangle and split it into components.